All right, guys, so welcome back from the Zoom disturbance again. Now, as I was saying, that our axis of symmetry is a line that cuts down the middle of the parabola, right at the point where you can fold over. If you think of folding over the left side onto the right side, it will fit perfectly well. Just like when you have a heart and you draw a line down through the center of the heart and you fold it, it should be able to fold perfectly on the left side, and the right side should fold perfectly together. All right. So the axis of symmetry for the parabola is that line that passes right through the center there where it is folded. All right, but for this axis of symmetry, just knowing the equation, we can calculate the x value, and the x value is given by this formula. So wherever this x value occurs on your line, by putting in these values minus b over 2a, you will find the x value through which the axis of symmetry will pass. All right. So once you have your equation, y equal ax squared plus bx plus c, and remember now, with the actual quadratic equation, you will get values for a, b, and c, numeric values. So when you put those numeric values in this formula, you will have minus b over 2a. So whatever value b is and a is, you put it in here and do the calculation. And then you will get an x value. And wherever that x value falls, that's the point through which the axis of symmetry will go. All right, guys. So just to show you what that should look like. So that would be the axis of symmetry, and the x distance from the vertical axis to the axis of symmetry is given by that formula. All right. Now, that is the x value. So the x value of symmetry would be the value right here. The x value would be right here. Now, if you continue with that line going all the way down, now to the point, to the bottom of the curve, what you can also determine, you can determine the y value. You can determine the y value at the bottom of the curve. And the y value at the bottom of the curve, you just draw wherever the axis of symmetry line come down, you draw a horizontal line right across, and then you read out the y value at the bottom there. And that y value, in this case where the curve curves down, that y value at the bottom of the curve is referred to as the minimum value. Now, if the curve had turned up and looked like a mountain, the y value would be at the top of the curve. And in that case, it will be known as a maximum value. Now, the x value and this y value at this bottom of the curve, we put those two values as a coordinate. So the x value of symmetry and the y value of minimum would be right at the center. That would occur right at the center where the axis of symmetry line is. It will occur right here. And so that point, we refer to it as the turning point, right? Because it is a point at which the curves start to change the direction. So if you think of it, you're coming down a slope up an hill and you reach to this turning point, then it start to turn and then go back upwards. And that's why that point is called a turning point. That's the point where the curve begins to turn back up. All right. Any question, guys? Everybody is clear? So if you want to calculate the X values for the axis of symmetry, you use this formula here. Now, there's also a formula that you can use to calculate the Y value for the minimum value. Now, all you have to do to get the Y value for the minimum value is that once you calculate the axis of symmetry, which is the X value, whatever value you calculate for X at the axis of symmetry, you plug in that value back in the Y equation where the X is. So put in that values for X. And then now you calculate the entire equation to get the value for Y min. And that will give you the minimum value. Is that clear to you guys? Any question? Raise your hand if you understand what I've just explained. Anybody? Any question? Is it clear? Guys, you have to respond so I know whether or not I can continue. All right, it's clear to Ms. Green. Anybody else? All right, if you are not, Ms. Cabrera, is it clear to you? Ms. Waysam, is it clear to you? Are you guys hearing me?
Sir, you can go over
Sorry,
one more.
when you're talking, sometimes it cut out.
Okay. So
You're kind of here.
all right, so all I'm saying is that if you have the equation y in the quadratic form, and you know the value for A, and you know the value for B, you can put that value for A and B from the quadratic form into this formula. So you put the B above, and you put a minus sign, so you have a minus B. And then you put the A below and times it by 2. And then now you do the calculation. So this A would be some value, the B would be some value. So you multiply the A by 2, or the value down here by 2, and then you use it to divide the numerator. And so you will get the value for the X value right at the symmetry here, which would be the X on this line coming right down here. So this X value would be calculated using this formula. All right. Now, once you know this X value, you know that the line of symmetry is going to come right down through that X value to the bottom of the parabola. Now, I'm saying that to the bottom of the parabola, if you go across, you will get a Y value known as the minimum value. Now, if the parabola was turned the other way around and shaped like a mountain, you would look for the Y value at the top of the curve. And in that case, it would now be called a maximum value, because maximum is above and minimum is below. But you get a maximum value when your curve looks like a mountain, and you get a minimum value when your curve looks like a valley. So you know that when the coefficient of X squared is negative, you're going to have a maximum value. When the coefficient of X squared is positive, you're going to have a minimum value. Now, to calculate the Y value, you can simply substitute the X value for the minimum for the axis of symmetry back in the formula. So let's say you calculate X here, and X was, say, 3. When you calculate it, you get X to be equal to 3. So wherever X is in this equation up here, you're going to replace the X squared with 3 squared. So that will become 3 squared. And then now you would have plus B times, and this now you put in the value of 3 again. And then you plus the value for C. But remember now, A, B, and C going to have values, so you can do the calculation after you make those substitutions for X. And you will get the minimum value for Y. Is that clear now, guys? Guys, is it clearer now?
It's like it's a vice versa thing because based on your explanation, if you flip it around one way, it mean one thing, and if you turn it the other way, it's the other. It's like
What,
you have plus or minus or something like.
but what is important for you to understand, Miss Dorothy? Remember, we say that our parabola can take two shapes. It's either it look like a mountain or it look like a valley. So if it look like a mountain, the turning point going to be at the top, right? And if it look like a valley, the turning point going to be below. So we are saying that if the turning point is below, the Y value at that time, we call it a minimum value. If the turning point is above, in that case, we call it a maximum value. So it will be based on the particular curve that you plot. If you plot a curve where the number in front of the x square is negative, you're going to get a curve looking like a mountain. And then now at the top of the mountain, you're going to measure the Y value. And that will be the maximum value for that curve. You get what I'm saying, Miss Dorothy?
Yes, sir, I'm following.
Right. But in both cases, whether you have a valley or a mountain, in both cases, you're going to use the axis of symmetry value to calculate the value that we have. All right. So you take the value of the axis of symmetry, and you know how to calculate the axis of symmetry already. You just put it in the formula, x equal to minus b over 2a. It doesn't matter what equation you have. Just put in the value here. Because if the a is negative, then down here you're going to have 2 times negative a, and that's going to make your value go above. For the x value, it's still going to work out. You follow?
Yes, sir.
Right. So after you calculate the x value, so let's say you calculate the x value to be 3. All you want to do to get your y value is to plug in this 3 back into the y equation where the x is. You substitute x to be 3. So wherever you have x here, you replace it with 3. So you'd have 3 squared right here, and then now you would have x right here, and then you do your calculation. And so that would give you your y value, which is the y minimum if the curve look like this, or y maximum if the curve look like a mountain. That's all I'm saying.
Okay, sir.
Understand? All right.
Okay, I get this.
Okay. All right. So with that said, guys, that is what we can say about the axis of symmetry. There is an x value that you can use this formula to calculate. And then you know your line has to be drawn right through that x value. So it will be a vertical line, and you notice in this case it's a dotted line. So that would be right in the middle of the parabola. And then to get the y value, whatever that x value is, you plug it into the y equation and calculate the y value. All right. Now, this is important because it can help us to sketch curve rather than to plot them. Now, curve sketching is really not as accurate as plotting the curve, but sometimes it will save you time from going through to calculate all those values in the table. And in some cases, we only need to know what the curve looks like by way of a sketch. And so we don't necessarily need to plot a curve using all the values from the table at all times. Because as you know, that take up some time to do the calculation. So if we know where the axis of symmetry is, and we know where the turning point is, we know whether or not we have a maximum or a minimum, whether your curve look like a mountain or a valley. We can just sketch a curve right at the point of the turning point. You follow what I'm saying? It would not be accurate as when you plot it, but it will give you a good idea as to how the shape of the curve is. All right. Now, with that said, I want to touch a little bit on curve sketching. Now, curve sketching is a little bit, it's a process, and it will take you a little time to understand fully how to grasp the techniques. But there are some rules to curve sketching that when you're sketching a curve, to sketch out the graph, we need the following. So you need the turning points at the axis of symmetry. You need the point where the curve cuts the x-axis. You need the endpoints of the curve. All right, so those are 3 points that you really need when you're sketching a curve. Now, if you were to sketch the curve for this equation, y equal to x squared minus 4x plus 3. Now, from that equation, you should be able to calculate these points. So you should be able to calculate the turning points. You should be able to calculate where the curve cuts the axis, the x-axis, as well as the y-axis. And you should be able to calculate the points at the end because you have the 2 x values for the end. So it means that you can find the y value for these. How would you find the y values for these 2 x values? Anybody?
Sir, you draw up the same graph. The same look what's in the name table.
Well, you really don't need to go through and draw a table. The table is for when you're dealing with a lot of x values. But because you only have 2 x values, you just plug each one of them in this equation here and do the calculation. So for x equal -2, you plug in this equation -2 where the x is, and you calculate and you get the y value. For x equal +6, you plug it in the same equation where the x is, and then you do the calculation and get the y value. So we're going to practice how to do this. We may not have enough time to go through the sketching, but I'm just going to try to take the time out to kind of give you an idea how to calculate these points. All right, so let us start off first with our turning point. So if we want to calculate our turning point, we already know the formula to get the x value at the axis of symmetry. So what is the formula for that? So x would be equal to what? We just look at the formula a while ago. Don't tell me you guys are so forgetful that that formula disappears already. So it would be what? Minus x equal to minus b over 2a. All right, now from the equation that we have here, what would be the value for b? Remember, in the general form, the number in front, the x in the middle would be the b, and the number in front, the x squared would be the a, and the last number by itself, in this case would be 3, that would be c. So if we're using this formula, what values should we have in this formula? What should we put in for b?
4, sir.
All right, so when you're putting in the value though, don't overlook especially the negative sign. If you have a negative sign, you have to put in the negative with it. So in other words, b is -4. So now you're finding the negative of -4. All right, so that would be in the numerator for the formula. Now, what would be a? A would be the number in front of x squared. In this case, A would be what?
1, sir.
So A would be 1. All right, so note that A would be equal to 1 and B equal to -4 based on what we have here. Remember, there's always an invisible one here. So in the denominator down here, we are multiplying 2 times A. So in this case, we would multiply 2 times 1. And so doing this calculation, now we have negative times -4. At the top, we get +4. And in the denominator, we would have 2 times 1, give you 2. And now we divide 4 by 2, we get what?
2, sir.
All right, so that means the x value for the axis of symmetry will be 2. Now, how can we calculate the y value for, in this case, would we have a y min or y max? How can we calculate the y value? Y min or y max, students? How do we calculate y min? Remember now, we're using the same y equation up here. So wherever x is, we're going to replace it with the 2. So here we would have 2 squared. So that would be the x value for the symmetry. 2 squared minus 4 times the x value again would be 2. 4 times 2 plus 3. Now we do that calculation. If you square 2, you get what? Come guys, squaring 2,
4,
you get
sir.
4. So you get 4. And if you multiply 2 times 4, you get what?
8, sir.
Right, and then you have a +3 here now. So when we simplify this, how many positive values we have here?
2.
All right, when you add those 2 positive values, what you get?
7.
All right, so now you would have
7
positive
minus 8.
minus 8. All right, so what would that give you for your answer?
-1.
-1. All right, that means the y min value would be -1. So your turning point would have a coordinate of what? What would be the coordinates at the turning point? You put in your x value for the axis of symmetry, and that would be what? 2. And the y value for y min, which would be -1. So that would be the turning point. So mean on your graph, when you're going to sketch, you look for that point, and you highlight that point. So the other points that you need would be where the curve cuts the axis. So you have 2 axes. You have the y-axis and you have the x-axis. Now the curve cuts the y-axis when the x value is 0. Now, so curve cuts y-axis when x equals 0. All right, so all you have to do in the y equation, you put x equals 0. So you would have y equal to 0 squared minus 4 times 0 plus 3. What would be the answer for y here? What would y be?
3, sir.
3, right. So it means that the curve would cut the y-axis at y equal 3, right? So wherever the y on the y-axis, you look for 3 on the y-axis and you make a point there. So that would be x equals 0 and y equals 3. So that point would be 0, 3. X equals 0 and y equals 3. All right, now the other one now is where the curve cuts the x-axis. Now the curve cuts the x-axis when y is equal to 0. So curve cuts x-axis cuts x-axis when y equals 0. So it means that in the same y equation, if you put y equals 0, you would have 0 is equal to x squared minus 4x minus 4x plus 3. Now, what you have to do here is to factorize this quadratic, if you can factorize it. Anybody remember how to factorize this?
Yes, sir.
Two numbers that you multiply to get 3, when you add them, you get negative 4.
-1 and -3, sir.
All right, so it is -1 and -3. Good. So it means that when you factorize it, you will get x minus 1 and x minus 3 equals 0. And then now you can solve for these x value by equating each bracket to 0. So you equate the first bracket to 0. Then you solve for x. So x would be equal to 1. You bring over the 1. And then the same thing for the other bracket, x minus 3 equal to 0. You bring over the 3, so x is equal to 3. So it means that the curve going cuts the x-axis at 1 and 3. All right, so those are the points that you would need to sketch a graph. So once you find those points, you could just connect those dots and you should get a sketch of the parabola without plotting the entire table. Is that clear? All right, guys, I think we have come to the end of this session. Any question before I stop here?
Sir, where does your eraser come from?
This 0, the y equals 0.
Yes, sir.
All right. Now, why we say it cuts the y-axis when it cuts the x-axis when y equals 0, that is based on the graph itself. So if you have a curve and the curve goes around, you know that it cuts the x-axis right here, and it cuts the x-axis right here. But the value of y would be 0 here. You follow? Because on the x-axis, you're neither going up or you're neither going down for y. So y would have to be equal to 0. Is that clear?
Yes, sir.
All right. Next class, we can look a little closer on that so that you can get more clarification. All right. So we're just going to stop here for tonight, and then now we'll continue tomorrow. All right, guys. So, all right, so I'm going to clear the screen.